So today I would like to tell you about our journey for evolving our web application into a microfrontends architecture. As a startup, we strive to continuously improve our application by adding new features. And presentation doesn't go. Okay, good. By introducing new features, improving the existing features, and to do that, of course, we need to grow our team while maintaining our agility. So what's the problem with that? Well, the problem is that if you grow in size and complexity, if the application grows in size and complexity and the team also grows, then development starts to become slower, more expensive, sometimes cumbersome, and it can even become risky at times. So it's easy to get into errors that might end up on the face of your customers. And so these are problems, we analyze these problems, and they are inherent to our monolithic front-end architecture, meaning there are inefficiency in the pipelines, in the sense that the more code you have, the longer it takes to build it, lint it, test it. There is interference between code owned by different squads that is all inside the same monolith. There are blockers to innovation because you want to try a new tool and you have to do it for the entire monolith, and there might be parts of the monolith that are not ready for the new tool. And then there are also, this also creates dependency between squads. I want to change a feature and touch some code that is owned by another squad. I have to liaise with them, align with them, and this might introduce delays. And finally, the fact that all the code is together makes it more difficult to assign ownership and solve tech debt. And these are not just theoretical things, these are all problems that we have experienced at TravelPerk. In our code base, we are talking about around 1 million lines of code in JavaScript and TypeScript. We have more than 14,000 unit tests. And what is important is that the size almost doubled in the last 12 months, and the cost for running our tests more than doubled in the last 12 months. So we can expect this trend to continue. This poses, of course, several challenges. One of those is the flakiness of the tests. If one test over 14,000 fails, then the entire pipeline or that particular job needs to be rerun, and that job might be very expensive to rerun and might create frustration. It might delay our time to production. So a little bit more than 1 year ago, we sat down and we tried to set what our vision was for our web application. We wanted to have independent deployability of features. So features should be encapsulated and we should be able to deploy them as one unit. Team decoupling so that we remove dependency the most possible and we try to accelerate the development. At the same time, we wanted our customers to perceive our application as one consistent user interface, as a unique platform. And we wanted to have all of this in a simplest scalable infrastructure possible, meaning that we wanted to be able to scale up our infrastructure in an easy way. And the answer to these ideals was after our analysis, moving to a front-end micro-frontends architecture, because it allows independent deployability in the sense that in a micro-frontend architecture, you can encapsulate a big feature inside an independent application that is deployed independently and that is composed on the client side. We decided to go for client composition. There are several types of compositions for microfrontend. I won't enter this particular topic, but we went for client-side composition, meaning that all the different microfrontends are composed inside the user's browsers. And then It also includes an easy, scalable, and secure deployment infrastructure. More of this later in the presentation. And in order to have a consistent user interface, we realized that it was needed to introduce a design system. So we introduced it. It's called Suitcase. I will tell you a bit more later. In terms of implementation, we opted to use a single SPA, which is one of the most popular libraries for implementing microfrontends. Sorry. And so the values for TravelPerk were many. We speed up development because we reduce dependency between squads. Each microfrontend is developed independently. We reduce blockers because now if we want, we can test a new tool just on one microfrontend, and then if it works, then move it to the other microfrontends. We can even try to test new versions of libraries just in one microfrontend. We boost efficiency by isolating and reducing technical debt because there is a clear ownership on the projects. We can say that one microfrontend is fully owned by one squad. We reduce interference and also reduce the blast radius of failures. And there is one example later in the presentation about this. And then we grow our product while maintaining cost under control, because smaller application means faster pipelines. And it means that if I need to modify one part of the application, I don't have to rerun the entire pipeline. I just rerun the pipeline for that particular application. So I don't know how many of you are familiar with the concept of microfrontends. So what is a microfrontend? I looked for a definition. A microfrontend can be defined as a microservice that exists within a browser. From a more philosophical point of view, we can say that microfrontends are development pattern where web applications are composed of independent fragments that can be built by different teams using different technologies and can be deployed independently. Okay, in general, microfrontends are modules in which you can decompose your web application. And here there are a couple of ways that you can use to compose microfrontends within your final application. You can have horizontal splits where the same page is served by multiple microfrontends, each microfrontend rendering one part of the page. Or you can have a more vertical split, where each page is one microfrontend. Then by moving from one page to another, you move from one microfrontend to another. And there are a variety of technologies that you can use to implement that. The reality is that in most of the cases, if you want a reasonable user experience, you use a mixture of the two. So here, for example, we see one page in the TravelPerk application. We can think that there is a container that loads two microfrontends, one that serves the navigation. And as you can imagine, the navigation will be the same for all the pages, but then the main content of the page is served by an independent microfrontend. And even if we have two microfrontends on the same page, you can consider that mostly as a vertical split, in the sense that each page will be served by an independent microfrontend, except for the navigation. But then you can also have pages where the main content is split into different microfrontends, and the split is mainly done based on the ownership of the domain that is represented in that fragment. So for example, here we have an itinerary page where the itinerary, the bookings are mainly served by the itinerary microfrontend, and then there is a right part about that is all about payments, and so this is served by another microfrontend that is owned by the payment squad. And then we can also have components that are exported individually and used inside other microfrontends, like the traveler's pill that you can see there in the middle, that is exported as a single component by the people microfrontend. Okay, so, and this is more of an horizontal composition. And in general, in our website, we realized that we need to use either a vertical or a horizontal composition in different pages. And the criteria is always the ownership of the material that is being displayed by that microfrontend. So that we make sure that people that work on that code are the people that own that particular domain. Now, as I was mentioning, we needed to create our own design system to make sure that the experience was consistent between all the microfrontends, and we did it. It's called Suitcase, and it contains many components that can be reused, but it also contains guidelines on colors. We are using a tokenized system, guidelines on layout, spacing, etc. And we are constantly developing it. To implement microfrontends, we use the single SPA. A few words about this library. Single SPA is, defines itself as a JavaScript framework for front-end microservices. Okay, microfrontends. In reality, it is a relatively light wrapper around some well-established standard APIs, the history API, the ES module API, and ES modules, not really an API, and import maps. And single SPA application consists of two things. One is the container that is called root config. That is the one that orchestrates the loading and the mounting of the different microfrontends. And then there are the applications themselves, the microfrontend applications. And those applications are just objects that need to export three methods. One for bootstrapping the application, the first time the application is loaded, and then methods for mounting and unmounting the UI from the DOM. The root config work, as I was mentioning, as a container. It orchestrates the loading, the mounting, and the unmounting. It provides the index.html file, and it also loads the general services. Think about tracking like Segment, Sprig, whatever, or monitoring like Datadog, New Relic. Most of the times they are based on singletons on the window object, and so they need to be loaded only once, and the container is the one that takes care and has the responsibility of loading them and providing those services to the other microfrontends. It also defines the general layout, and single SPA has a very nice functionality where you can define the layout, the application with a router-like configuration. Here you can see that in the page, you have the navigation part that is served by the microfrontend navbar, and then we have, if we are browsing to the settings path, then we will load the settings application. But otherwise, if we are browsing to any other path, we will load the main application. And finally, there is a chat application that is loaded always, regardless of the path. So this means that single SPA orchestrates the loading and mounting and unmounting based on the path, mainly based on the path that you are browsing. And of course, this allows you to improve the performance of your application by loading only the things that you need based on the path that the user is browsing, and lazy loading the applications. I forgot to mention that applications are lazy loaded directly in the browser as ES modules, so they are loaded dynamically. And this is why single SPA leverages ES modules. Now, in order to create a single SPA application, you can use whatever framework you're used to use, and there are very convenient adapters that will take your main component and will create for you the lifecycle methods that you need to mount and unmount that application in single SPA. So if normally you would just React DOM render your main component, in single SPA you just have to wrap your main component inside an object by using the single SPA React plugin, and this will return automatically the three methods that you need to load the application. And there are such type of adapters also for Vue and Angular. As I was mentioning, ES modules are the official standard of module system in JavaScript, and they are used to dynamically load the microfrontends. Now, if you use ES modules by default, then you will need to use a syntax like this. So you would import something from, and you have to specify the URL of the bundle that needs to be loaded. And of course, we don't like hard coding URLs in our code. If we change the URL, you have to change it in all your code. And this is where import maps come to save the situation. Import maps are just an almost standard. It's implemented in all the main browsers, and it's becoming a standard as we speak. And it allows you to define a map between identifiers and the corresponding URL that serves the bundle that correspond to that identifier. So instead of writing this, you can write this, and then whenever you change the deployment of your bundle, you just modify the import map. The import map is inside the index.html file, and it can also be served as a separate JSON file. And this really simplifies the deployment and the rollback of a version of your application. Okay. So what has been our journey towards microfrontend? The first thing we did was, and it's something that I really recommend doing if you want to move towards a microfrontend architecture, is a proof of concept, where we try to extract the chat component, which is the one that you see there on the bottom right. We try to extract this chat component into a separate microfrontend. And this allowed us to verify the feasibility of such a thing, understand what were the challenges and the problems that we would face, and plan the real migration with a lot more confidence. We also were able to test the changes to our deployment infrastructure. And this was really good because it really allowed us to create an infrastructure that served us well. So what we did was we took the main monolith, and first of all, we started creating a container, the root config that I was talking about before, and we migrated the monolith into a monolithic microfrontend. So we transformed this monolith in a microfrontend. And then once we had that, we could isolate the chat component inside the monolith and extract it to its own microfrontend. The proof of concept was successful, so we moved on to the real migration. And as I was mentioning, we were really able to test our deployment infrastructure, where each microfrontend is a completely independent project. It is inside the monorepo, but it's an independent project. So it's only rebuilt, and there is a pipeline that runs only if you change the code of that specific microfrontend. So we have the definition of one pipeline for each of the microfrontends that we have. Each microfrontend is built and deployed independently to a separate storage unit. In this case, it's an S3 bucket. Import maps simplify the process of releasing and rolling back, because once you have deployed a new version, you just have to modify the import map to have that new version available for our users. There's a bit you need to do to serialize the changes to the import map, but in general, it works pretty well. So one of the nice things that we realized in moving towards microfrontend is that we needed to rethink the way different parts of the application were communicating to each other. In a normal application, you would just, if you need one component to do something with another part, with another component, you would just export a function and then you call this function and you're done. If those two elements are inside different applications, then it's more difficult to do that. And so you need to use other APIs. And so we discovered the broadcast channel API, the custom event API. You can also use routing parameters. Yeah. To communicate. There are other ways like the local and session storage. They're still available because all our microfrontends are served under the same URL, sorry, under the same domain. And you can even use the browser memory by exporting some functions. But the three methods that are above the line are the one we suggest the more, because they improve the coupling. So as I was mentioning, if before, in order to show the chat, we had to just call a function start chat that was in the chat component, when these two elements are in two different microfrontends, we had to change it and then send an event from one microfrontend and add a listener in the other microfrontend that would react to that event by showing the chat. And the advantage here is that if this start chat function throws an exception, in the monolith, the page is screwed. And instead, here, you just have the chat microfrontend that won't work. So the worst you can get is that the chat doesn't appear, but the rest of the application continues working. It's still an ongoing journey. So we are really getting a few gains, like we are forcing to refactor code to separate concern. One is the authentication module. We realized that those concerns were spread across the monolith, and instead now we are trying of separating those concerns into a different microfrontend. And this really simplifies the code. It allows for a better troubleshooting. It allows you to set boundaries between domains, preventing the famous big ball of mud of your code that always happens whenever you have a monolith. You can have faster pipelines. Really, now deploying the chat just takes a couple of minutes, and instead, before any change, should go through all the 20 minutes of our main pipeline. And then you can start from scratch on new features. And I can't overstate how good this is, because you can have faster iterations. You start on a white slate, and it really allows you to concentrate on your code. There are a few challenges. So you need, microfrontends are not easy to use. And so we needed to create scaffolds and templates to make it easier for people to start creating their own microfrontends. We had to refactor the tooling into separate packages, because before they were in the monolith and now they have to be used by the different projects. So we had to refactor them. Sometimes extracting microfrontends from the monolith require large refactorings. And one thing that is particularly true is that testing becomes a bit more complicated. And this is because if you're importing things from another microfrontend, and that microfrontend is a dynamic module that is loaded at runtime, then in your test environment, that module is not available, which means that you have to mock it everywhere. On the other side, you can introduce integration testing, and this is one of the good things. So if you're working on a microfrontend and you're changing that microfrontend, and so inside your branch, you have the changes to that microfrontend, then it's easy to test those changes in integration with all the existing other microfrontends in production, because the composition is done in the browser. So if you set up the import map, then your browser can just load all the microfrontends from production except the one that you're modifying that is loaded from local. And then you can run Cypress or whatever other tool you use to test it. And this is, I think this is a really nice feature. So this is more or less everything that I wanted to say. If you're interested, I have a video in my YouTube channel that explains how single SPA works in its core. It's a live coding session. I think it's fun to watch. So feel free to have a look at it. And for the rest, I'll be happy to take questions.
First of all, good presentation, really super interesting. Like, what is the success matrix that you have in place to be able to call it like a successful project? I mean, you say that it's still ongoing.
Yeah, so we're still in the process of defining completely those metrics because we are relatively new to this field. Our ideas are around efficiency in terms of the average time of pipelines as we move. Another metric is the success rate of our tests, and we are planning to measure the level of coupling between different parts. We have some tooling in place to link our code to avoid wrong couplings, so dependencies that go in the wrong direction. And we want to generate tooling for measuring the level of coupling by counting basically how many dependencies are in the wrong direction inside our code base and how many of those we can be solving by moving towards microfrontends. And I'm sure we will find more and more metrics as soon as we go more and more into this architecture.
Thank
you. Okay, this is interesting. Thanks for the presentation, by the way. I haven't used a single SPA so far, only the module federated version. My question was around shared dependencies. So whether it's React or the design system that you mentioned. How do you deal with them? And obviously, how do you avoid having 70 Reacts in your application?
Yeah, absolutely. I didn't mention that, but of course, import maps allow you to have shared dependencies. So the moment you, for example, for React, React DOM, React Query, so all those libraries that you plan to use in all your microfrontends, you don't want to bundle them. And so you will just enter an entry in your import map that maps React to the corresponding URL of the bundle. And then you declare those dependencies as externals in your Webpack or Rollup or whatever bundle you're using configuration. And they will be loaded by the browser the first time they're used. And yeah, this is how we do it. It's really that simple.
Okay, can I have a follow-up question? Then how do you deal with upgrades, which is one of the problems I found with microfrontends? You were mentioning that you can just release, one microfrontend at a time. But obviously, if you do an upgrade of a version, which is a shared library, you have to test everything, right? Do you have every 2 weeks that, let's say you upgrade to the latest React version, you need to test every single microfrontend.
Absolutely.
Same for the other libraries, right?
Exactly. So you cannot just upgrade for all the microfrontends at the same time, or at least this is very difficult. So one advantage of this setup is that import maps allow you to have scoped definitions, meaning that you can use a certain version of React under a certain path and another version of React under another path. We are serving microfrontends under different paths, so we can decide we will use React 18 for TK Web, and we will use React 17 from TK Support Chat, for example. Now, it's not that easy, of course, and this is what I'm saying is purely theoretical in the sense that we never did it in reality. But in principle, there is this possibility, and so you could upgrade versions of certain libraries, one microfrontend at a time, until all of them are working, and then you can completely remove the previous version. And this allows you to have a more iterative approach to upgrades.
Yeah, I got you. Thanks. I'll ask, but after I want
Absolutely.
To pass this to someone else.
Let's talk about it.
Hello. So my question is, do you think there's a threshold for an app to be too small for microfrontends? So
absolutely, yeah. Microfrontends are not for everyone. So there is an inherent complexity in the microfrontends that need to be taken into consideration. So just preparing all the tooling and the foundational code for squads to be able to generate their microfrontend is a significant amount of work. And I would suggest that if you do it, your company has a team dedicated just to the maintenance of that tooling and that code. I find, so in our case, we started thinking about microfrontend when we were approaching the 1 million lines of code, and we were getting more than 10,000 unit tests, because then we could really start suffering from the flakiness in the pipeline and the complexity in starting adding new features and those huge modules that we wanted to clean up. And so whenever you start feeling those pains, then it's probably the time to start considering moving to our microfrontends, but only if you have the resources to do that, taking into account that you need to really dedicate a team to that.
Okay, so would it help to design it like some kind of modular monolith? And then...
Exactly. So this is one of the learning that we had, that when you start splitting the code, then you realize what parts of your code are not good to be extracted. And then you think, okay, next time I do an application, from the beginning, I will try to structure better my modules and put in place some linting that forces my team to keep that structure. One tool that was very beneficial to us is Dependency Cruiser, which is an application, which is a tool, a library that allows you to check for dependencies in the wrong direction. So you can set rules and say module A cannot import from module B. Module B can import from module A and D. Yeah, and then you draw your architecture, and if anyone starts introducing the wrong type of dependency, their PR will be blocked. And this really helped us.
Okay, thanks.
Hey, thank you so much for your talk, Roberto. I arrived late, so maybe you mentioned that before. Did you have any estimation of how long it will take you to migrate completely to microfrontends? And how's it going?
Yeah, so we have some ideas about that, and we have a planning internally. Unfortunately, I cannot share yet that answer. Maybe we can talk about it after the meeting. It's certainly a very long process. So refactoring such huge applications take time, and we're talking about quarters, of course.
Okay, thank you. And you just mentioned that some kind of threshold that when you feel that you need to migrate, or maybe there is an opportunity to migrate to microfrontends, when there is, all that issue that you mentioned, could it be something else but not migrate into the microfrontends? Because then, I mean, you need to, you mentioned that you have a separate team.
Yeah.
That's
yeah, sure. Yeah, so let me put it this way. There are many ways in which you can solve your problems. For example, 2 years ago, our development server was taking too long to start. Yeah, and then there you could have said, oh, microfrontends, fantastic. You split it down, smaller code base, Webpack will start much faster. But then at that time, we decided to move to Vite, that had on-demand translation and could start the development server in a few seconds. Everybody was happy. But then you solve part of the problem, but you don't solve the other part of the problem. So there are patches that you can put to keep going on, even on a large monolith. But our experience is that problems will continue accumulating, and you need a solution that is structural in its nature.
Nice, thank you. Yeah.
And I think this was the time for the last question. So,
do we have the last one, or?
Oh, okay. There's one last question here.
Hey, hello. Yeah, my question is about the navigation, to keep the single page application navigation, no? How is managed this routing part in the client?
Okay. Yeah, so single spa integrates with the router of your application. So single spa manages just the loading and mounting and unmounting of the application based on the path that you're navigating, but then your internal router will continue working. So if you use React Router, for example, you have single spa that decides, okay, under settings, I need to load the settings microfrontend. And then inside microfrontend, you can have your router that that decides which component to render based on the subpath under settings. And so I don't know if this answers your question. So you don't need to reload the page. It's all handled by the history API.
To understand the routing part, no, the React router will be in the layout part, and then the content is the microfrontends, or how it works.
It's not exactly like that. So the single spa router will just help single spa decide which microfrontend app needs to be loaded, mounted, and unmounted. Okay, so, and this will be the first thing that will happen. After the application is mounted, then control passes to the router inside your application. And if you're using Vue, you will have some router. If you use React, you will use React router,
So
etc.
you need multiple routers.
Absolutely. Each application will have its own routing. Yeah.
Okay.
Internal routing.
Okay. Now I understand. Thanks.
Thank you. Please, big applause again.